First, let me remind you formula for integration by parts. When we have integral of f of x times g prime of x with respect to x, this is equal f of x times g of x minus, and we have integral of f prime of x times g of x with respect to x. We have got function x times cosine of x. So we have product of two other functions. First is x, the second is cosine of x. And integration by parts can be useful if I can take the derivative of one of them and it becomes simpler, and if I take the antiderivative of the other one, it becomes no more complicated. Here we have x and cosine x. When we take derivative of x, we will have 1. So we will put f of x equals x. F prime of x, derivative of x, is 1. Now we have our first f of x equals x. Now what's left is our g prime of x. Let me put this here. We have g prime of x is equal cosine of x. So now we need to find antiderivative of cosine of x. This is equal sine of x. You can always check derivative of sine is cosine. So we have f g, we have f prime, g prime. So now we can just substitute to our formula. So our integral of x times cosine of x with respect to x is equal, we have f of x times g of x. So we have to just multiply x times sine of x minus, and now we have integral of derivative of f of x. So this is 1 times g of x is sine of x. So we have times sine of x with respect to x. Now we see that our integral is very simple. We have just integral of sine of x. So first we have to just copy x times sine of x minus, and integral of sine, let me rewrite this. We have integral of sine of x with respect to x. So this is equal, we have to rewrite x sine of x minus, and integral of sine is negative cosine. So I will put this in parentheses, negative cosine of x. And of course we have to add constant. So this is equal, negative and negative give us positive. So we have x sine of x plus cosine of x plus constant c. This is my solution. We need to integrate by parts. So first we have to write formula for integration by parts. When we have integral of product f of x times g prime of x with respect to x, this is equal f of x times g of x minus integral of f prime of x times g of x with respect to x. In our example, we have integral of x squared times cosine of x. So now we have to choose which function will be f of x and which g prime of x. Because we have x squared, so if we put f of x equals x squared, the derivative will be 2x. Our function becomes simpler. So we will put f of x equals x squared. So f prime of x will be 2x, and what left is cosine of x. So our g prime of x will be equal cosine of x. Now we have to find antiderivative of cosine of x is equal sine of x. Cos derivative of sine is cosine. So now we have to just use this formula. Let me rewrite our integral. We have of x squared times cosine of x dx. This is equal. Now first we have to multiply f of x times g of x. We have f of x equals x squared, g of x is equal sine of x, and we have minus and integral of f prime of x times g of x. F prime of x is 2x, g of x is sine of x, and we have with respect to x. This is equal. We have to copy x squared sine of x, and we have constant too. So we will take this constant before integral, and we have x times sine of x dx. Again, we have multiplication here. Again, we can use formula for integration by parts. Why? When we take derivative of x, it will be 1. Our function becomes simpler. F of x equals now x, f prime of x will be equal 1, and g prime of x is what left. We have sine of x. So now we have to just find antiderivative of sine of x. So g of x is equal negative cosine of x. Let's check. Derivative of cosine is negative sine. That's why I have to put negative here. Negative and negative give us positive. So now we have to copy the beginning. We have x squared sine of x minus 2, and now we will open the brackets, and again we will use this formula. First we have f of x times g of x, so we have x times negative cosine of x. Next we have negative sine and integral of f prime of x times g of x. F prime of x is equal 1, and g of x is negative cosine of x. And we have integral with respect to x. Close the brackets. This is equal. First we have to copy x squared sine of x. First I will copy negative 2, and in brackets we will have x times negative cosine of x will be negative x cosine of x, and we have negative and negative give us positive. 1 times cosine will be cosine of x with respect to x. Close the brackets. This is equal. This is equal. We have to copy x squared sine of x. Now we have to multiply by negative two expressions in brackets. So will be negative times negative is positive 2 x cosine of x. Negative 2 we have to put times integral, so it will be negative 2 times integral we have of cosine of x. Integral of cosine of x is equal sine of x. So we have 2 times sine of x. And of course we have to add constant because we have indefinite integral. So this is equal. We have x squared sine of x and negative 2 times sine of x. So we can factorize sine of x, and we will have x squared minus 2, what we have, plus 2x cosine of x plus constant c. We can put this expression before sine of x, so it will be x squared minus 2 times sine of x plus 2x cosine of x plus constant c. This is my solution. First, let me remind you formula for integration by parts. When we have integral of product f of x times g prime of x dx, this is equal f of x times g of x minus integral of f prime of x times g of x with respect to x. We have here product. We have x squared and sine of 4x. When we take derivative of x squared, we will get simpler expression. So we will put f of x equals x squared. So f prime of x will be equal 2x. What left? We have sine 4x. It will be our g prime of x. Next, we have to find antiderivative of sine of 4x. So this is equal negative 1 over 4 cosine of 4x. Let's check. Derivative of cosine is negative sine. That's why you have to put here negative sign. And because we have composite function, we have to next take derivative of 4x. Derivative of 4x is 4. So when we multiply 1 over 4 times 4, it will be 1. So everything will be okay. We don't have here any constant. So now we have to just replace to our formula. Let me rewrite our example. We have integral of x squared sine of 4x with respect to x. This is equal. First, we have to multiply f and g function. So it will be x squared times negative 1 over 4 cosine of 4x. Next, we have negative sign and we have integral of f prime is 2x times g is negative 1 over 4 cosine of 4x with respect to x. This is equal. Let's do simplification first. Positive times negative will be negative, and we will put first constant 1 over 4 x squared cosine of 4x. Next, we have negative and negative give us positive, and we can reduce 2 and 4 will be 2. I will put this constant 1 over 2 before integral, so it will be 1 over 2, and we have integral of x times cosine of 4x with respect to x. We see we have at the beginning integral of x squared sine of 4x. Now we got integral little simpler. We have x times cosine of 4x. Because we have multiplication, so we can use again formula for integration by parts. For f, I will put x because when I take derivative of x, I will get 1 and our function becomes simpler. So we will have now f of x equals x, f prime of x will be 1, and what left is cosine of 4x. It will be our g prime of x is equal cosine of 4x. We need to find antiderivative. So Antiderivative of cosine of 4x is 1 over 4 sine of 4x. You can always check. When you take derivative of sine 1 over 4 sine of 4x, we copy constant. Derivative of sine is cosine, and derivative of function which is inside is 4x. Derivative of 4x is 4. So 4 times 1 over 4 will reduce, and we got 4 cosine of 4x. So everything is okay. So now this is equal. We have to copy the beginning. We have negative 1 over 4x squared cosine of 4x. We have plus 1/2. And now I will put brackets. And again, we have to rewrite this integral to this form. So we have first f of x times g of x. So we have x times 1 over 4 sine of 4x. Let me put this in parentheses. And next we have negative sign. And we have integral of f prime of x. F prime of x is 1. And we have times g of x. 1 times 1 over 4 sine of 4x is 1 over 4 sine of 4x with respect to x. Close brackets. This is equal. We have to copy beginning. Next, we have plus 1 over 2, and first we will put constant 1 over 4x sine of 4x, and we have negative. We will take constant before integral. So we have integral of sine of 4x with respect to x. So this is equal. Now we got integral only of sine of 4x. So first we will solve this integral. Let me copy this. We have integral of sine of 4x dx. We will use substitution method. Let me put u is equal 4x. So we will have now to find derivative of both sides of our equation. Du to dx is equal 4. Derivative of 4x is 4. Now, because we do u substitution, we need to find du. So I will multiply both sides by dx. Dx and dx we can reduce. And we have that du is equal 4 dx. When we do substitution method, we cannot mix up x and u in one expression. So when I have sine of 4x, I will put sine of u. I will need to find dx. So we have here 4 dx. I will divide both sides by 4. So 4 and 4 we can reduce, and we have that I will change the sides. Dx is equal, I can write 1 over 4 du. So now we can solve our integral. This is equal. We will have integral of sine of u, 4x, I substitute by u, and dx is equal 1 over 4 du. Can put in parentheses. So this is equal. Constant I can take before integral. So we have 1 over 4 integral of sine of u with respect to u. This is equal. 1 over 4 we have to copy, and integral of sine is negative cosine. Of course, we have to add constant, And we have to come back to our substitution. We need to find integral with respect to x. So we will substitute u by 4x now. So we have negative times positive will be negative 1 over 4 cosine of 4x plus constant c. Now we'll come back to our expression. Beginning we need to copy, and integral of sine of 4x we have to replace by negative 1 over 4 cosine 4x. So this is equal negative 1 over 4 x squared cosine of 4x plus we have 1 over 2 times 1 over 4 in brackets x sine 4x minus 1 over 4, and now we have to put in parentheses negative 1 over 4 cosine of 4x plus c. Close brackets. This is equal, and we have negative 1 over 4x squared cosine 4x. Now we need to do multiplication. Let me start from inside. So we have 1 over 2, and in brackets we have 1 over 4x sine 4x. Negative and negative give us positive. Will be 1 over 16 cosine 4x. Constant times 1 over 4, it still will be constant, so I can put plus c1. This is equal. We have negative 1 over 4x squared cosine 4x. 1 over 2 times 1 over 4 is 1 over 8 x sine 4x plus 1 over 2 times 1 over 16 is 1 over 32 cosine 4x. Constant times 1 half still will be constant, so I can put c2. This is my solution. First, let me remind you formula for integration by parts. When we have integral of product f of x times g prime of x with respect to x, this is equal f of x times g of x minus integral of f prime of x times g of x with respect to x. We have multiplication here, so we can use this formula. Let's put f of x equals e to power negative 2x. Why? Because it's easy to find derivative of e to negative 2x. F prime of x is equal, derivative of e to power negative 2x is e to power negative 2x, and now we have to find derivative of function which is inside. We have negative 2x, derivative of negative 2x is negative 2. I will put this negative 2 before e. So we have f prime. Now what left? Sine 3x. So this is our g prime of x is equal sine of 3x. Why? Because we just use this formula f of x. I'll just put e to power negative 2x. So whatever left must be our g prime. And we need to find g of x. Antiderivative of sine of 3x. This is equal negative 1/3 cosine of 3x. You can always check. Derivative of cosine is negative sine. So that's why I put negative sign to reduce minus, because we don't have here. and derivative of function inside we have to calculate. Derivative of 3x is 3. That's why we have 1 over 3 times 3 will reduce, and we don't have here any constant. So now when we have g and f prime, we can use this formula. So let me rewrite our integral. We have integral of e to power negative 2x times sine of 3x dx. This is equal. We have f times g. So we have e to power negative 2x times negative 1/3 cosine 3x minus, and now we have integral of derivative of f, so it's negative 2e, let me put this in parentheses, to power negative 2x times g is negative 1/3 cosine of 3x with respect to x. So this is equal. We have positive times negative will be negative. First I will put constant 1/3 times e to power negative 2x times cosine of 3x. Next we have integral negative times negative, give me positive. So we have to put just negative 1. And we have 2 times 1/3 is 2 over 3. And we will copy integral of e to power negative 2x cosine of 3x with respect to x. We see that we still have integral of e to power negative 2x. We cannot change this. When we take derivative of e to power negative 2x, we have still the same function, nothing reduced. And we change sign. We have at the beginning sine, now we have cosine. Let's do one more time integration by parts. Again, I will put f of x equals e to power negative 2x. Derivative of f prime of x. F prime of x is equal, we have to copy e to power negative 2x, and derivative of negative 2x is negative 2. I will put at the beginning. Now we have g prime is what left is our cosine 3x. Antiderivative of g prime is 1/3 sine of 3x. We can always check. Derivative of sine is cosine. And now we have to find derivative of function which is inside. Derivative of 3x is 3. That's why you have to put 1/3 over 3 to reduce this 3. Now we have to use one more time formula for integration by parts. Beginning we have to just rewrite, so this is equal negative 1/3 e to power negative 2x cosine 3x, and we have negative 2 over 3, and in brackets first we have to multiply f times g, so it will be 1/3. I will put first e to power negative 2x, this is our f, this is our g, times sine of 3x minus, now we have to put first f prime, we have integral of f prime is negative 2, we have to put in parentheses e to power negative 2x times g, g is 1/3 sine of 3x with respect to x. Close brackets. This is equal. We have to simplify first. So beginning we need to copy 1 over 3 e to power negative 2x cosine 3x minus 2 over 3, and in brackets we will have 1 over 3 e to power negative 2x sine 3x. Negative and negative give us positive. 2 times 1/3 is 2 over 3, and we can put this constant before integral, and our integrand is e to power negative 2x sine 3x with respect to x. We see that we got the same function which we have at the beginning. Integral of e to power negative 2x times sine of 3x. The same what we have at the beginning. So what we do? First we just rewrite our function one more time. We have integral of e to power negative 2x sine of 3x dx, and this is equal, we have to copy negative 1/3 e to power negative 2x cosine 3x, negative 2 over 3 times, we have to multiply by 1/3, so it will be negative 2 over 9 e to power negative 2x sine 3x, and negative times positive give us negative. 2 over 3 times 2 over 3 is 4 over 9, and we have integral of e to power negative 2x sine 3x with respect to x. Next, because we have integral of e to power negative 2x sine of 3x on the left side and on the right side, I will move this part to left side. So beginning we have to copy, we have integral of e to power negative 2x sine 3x dx, and we have negative, so we have to change to positive. 4 over 9 integral of e to power negative 2x sine 3x dx. This is equal, what left is negative 1/3 e to power negative 2x cosine 3x minus 2 over 9 e to power negative 2x sine of 3x. We have here integral of e to power negative 2x sine 3x. We have the same integrand. So we have like 1 integral plus 4 over 9. So we can put this in parentheses. We have 1 plus 4 over 9 integral of e to power negative 2x sine of 3x dx. And we have to just copy the right side. Negative 1/3 e to power negative 2x cosine 3x minus 2 over 9 e to power 2x sine of 3x. Next, we can add these two numbers, so we need to have the same denominator. 9 over 9 will be, so 9 plus 4 is 13 over 9 times integral of e to power negative 2x sine of 3x dx. And right side we have to just copy negative 1/3 e to power negative 2x cosine 3x minus 2 over 9 e to power negative 2x sine 3x. Next, because we need to find integral of e to power negative 2x sine 3x with respect to x, we don't need this constant because we have multiplication here. We can multiply both sides by 9 over 3. 9 over 13 to reduce this fraction. So this will reduce, and we have integral of e to power negative 2x sine of 3x dx is equal. Now we have to multiply every expression by 9 over 13. So it will be negative 1/3 times 9 over 13 e to power negative 2x cosine 3x minus 2 over 9 times 9 over 13 e to power negative 2x sine 3x. Next, we can reduce 3 and 9 will be 3, 9 with 9. So this is equal. It will be negative times positive will be negative 3 over 13 e to power negative 2x cosine 3x minus 2 over 13 e to power negative 2x sine of 3x. Next, we can factorize negative 1 over 13, and because we have negative and negative, and we have e to power negative 2x and e to power 2x in both expressions, so it will be e to power negative 2x. We can factorize, and in brackets what left? We will have 3 cosine 3x. Negative we factorize, so we have plus 2 only because 1/3 we factorize sine of 3x. So this is my solution. First, let me remind you formula for integration by parts. Let me write this on the right corner. Integral of f of x times g prime of x with respect to x is equal f of x g of x minus integral of f prime times g of x dx. We have here multiplication, so we can use this formula. Let's see. First, I will put for x, for f of x, 1 plus x to 3rd power, because it's more complicated, I think, where x to 4th power. So now we need to find derivative of f. So it will be 3, 1 plus x squared. Next, what left? X to 4th power. So g prime, it will be x to 4th power. We need to find antiderivative of x to 4th power. This is 1 over 5 x to 5th power. You can always check when you take derivative of this function will be exactly x to 4th power. So now we have to just replace to our formula. Let me copy our integral of x to 4 times 1 plus x to 3rd power dx. This is equal. First, we need to multiply f times g. F times g, so we have 1 plus x cubed times 1 over 5x to 5th power. Next we have negative sign, and integral of f prime is 3 times 1 plus x square times g. G is 1 over 5x to 5th power with respect to x. We have at the beginning 1 plus x2 cube. Now we have 1 plus x2 second power. So we can do one more time integration by parts to reduce this expression. So let me first do simplification. So this is equal. We have to put first constant 1 over 5. Next we have 1 plus x to cube, x to 5th we have to copy, and we have negative sign. 3 times 1 over 5 we can take before integral. So it will be 3 over 5, and we have integral of 1 plus x square times x to 5th power with respect to x. So next we can one more time use integration by parts, or you can take 2 square 1 plus x and you can do integrals of power function formula. But let me do one more time integral by parts. So I will put now that f of x is equal 1 plus x squared. So f prime of x is equal 2 times 1 plus x. Our g prime of x is equal x to 5th power. So antiderivative will be 1 over 6 x to 6th power. So now we can replace to our formula f and g first. So let me copy the beginning. We have 1 over 5 times 1 plus x to cube times x to 5th power minus, we have to copy 3 over 5. Now we'll open brackets, and now we have to just substitute to our formula. F times g, so we have 1 plus x square times 1 over 6 x to 6th power minus, and we have integral of f prime is 2 times 1 plus x, and we have g is 1 over 6 times x to 6th power with respect to x. This is equal. We have to close brackets. So now the beginning we need to copy 1 over 5, 1 plus x cube, x to 5th power minus, and let me copy first 3 over 5, and in brackets we can do simplification. First I will put 1 over 6, next we have 1 plus x to square, x to 6th power, and now we can reduce 2 and 6 will be 3, so 1/3 we can put before integral, and we have integral of 1 plus x times x to 6th power with respect to x. What now we can do to find this integral? We can do one more times integration by parts, or you can do multiplication here. Let's do multiplication now. So this is equal. The beginning we need to copy 1 over 5, 1 plus x cube, x to 5th power, and now we have to multiply negative times positive will be negative, 3 over 3. We have 1 plus x square, x to 6th power minus 1 third times integral of 1 times x to 6 power is x to 6 power plus we have x times x to 6 power is, we have the same base, so it means we need to add exponent. Here we have invisible 1. 1 plus 6 is 7. This is integral with respect to x. So this is equal, oh, I forgot to multiply 1/3 by 3 over 5. So it will be 3 over 15. We can reduce, so it will be 1 over 5. So now this is equal. We have 1 over 5, 1 plus x cube, x to 5th power, minus 3 over 3, 30 we can reduce to, so will be 10, 1 of 10, 1 plus x square, x to 6 power, and we have negative 1 over 5. And I forgot to change the sign because we have here negative times negative, so here we will have positive 1 over 5. And we have integral of sum, so this is equal sum of integrals. So integral of x to 6 power, we need to use power formula, so this is equal x to power 6 plus 1 is 7 over 7. I will put this in parentheses, plus integral of x to 7 power is x to 8 over 8. Of course, we need to add constant. So this is my solution. First, let me remind you formula for integration by parts. When we have multiplication like here, we have x squared times e to power x, we can use formula integral of f of x times g prime of x with respect to x is equal f of x times g of x minus integral of f prime of x times g of x with respect to x. Because we have here x squared and e to power x, we know that derivative of e to power x is still e to power x, and derivative of x squared will be 2x, so the power will reduce to 1. So we will put f of x is equal x squared. So f prime of x will be 2x. Now, what left? We have e to power x. So, our g prime of x is equal e to power x. And the derivative of e to power x is e to power x. So, now we can use this formula. We have everything. So, our integral, let me rewrite, of x squared ex with respect to x is equal f times g, so we have x squared times e to power x minus integral of f prime is 2x times g is e to power x with respect to x. We see in our integral we reduce power of x to 1, so we can use again integration by parts formula. So this is equal, let me copy, x squared e to power x, we have minus, and first I will take this constant before integral, so it will be 2 times integral of x times e to power x with respect to x. So now, to solve this integral, I will put that f of x is equal x. Why? When I take f prime of x, it will be 1. So our function will be simpler now. And what left? We have g prime of x is equal our e to power x. Antiderivative of e to power x is e to power x. So we can rewrite our beginning. So we have x squared e to power x minus 2. I will open brackets, and first we have to multiply f times g. Now f is equal x, g is equal e to power x. So we have x times e to power x minus, we have in formula minus sign, and we have integral of f prime is 1 times g is e to power x with respect to x. So this is equal. We have to copy x squared times e to power x minus 2, and we have in brackets x times e to power x minus 1 times e to power x is e to power x. Integral of e to power x is e to power x. We have to add constant. What we can do? We can do multiplication. So this is equal x squared times e to power x minus 2x e to power x. Negative and negative give us positive 2 e to power x. Negative 2 times constant will be still constant, so we can put plus c1. Next, we can factorize e to power x. So this is equal e to power x, and in parentheses we will have x squared minus 2x plus 2 plus constant c1. This is my solution. We need to use integration by parts formula. So first let me remind you, when we have integral of product f of x times g prime of x with respect to x, this is equal f of x times g of x minus integral of f prime of x times g of x with respect to x. Because we have here x to 4 power times e to power 2x, I will take f of x equals x to 4 power. Why? When we take derivative of x to 4 power, we will reduce. The power will be x to 3rd power. So it's a good idea to take f of x equals x to 4th power. So f prime of x will be 4x cubed. What left? We have e to 2x power, so this is our g prime of x. We just use this formula. When we put f of x equals x to 4th power, whatever left must be our g prime. So e to power 2x. Now we have to find antiderivative of g prime. So this is equal e to power 2x, and we have to multiply by 1/2. Why? Because derivative of e to power 2x is e to power 2x, and derivative of 2x is 2. So when we multiply 1/2 by 2, this constant will reduce, and we will have exactly what we have at the beginning. G prime is e to power 2x. So now we can use this formula. Let me rewrite our integral of x to 4th power e to power 2x with respect to x is equal x to 4th power times f times g, so 1/2 e to power 2x minus, and now we have integral of f prime is 4x cubed times g. We have g is 1/2 e to power 2x dx. This is equal. First we will put constant, so we have 1/2 x to 4th power e to power 2x, and we can reduce 2 with 4 will be 2. I will put this constant before integral, so we have minus 2, and integral of x to third power times e to 2x dx. We see our function is now simpler, so we need to use again integration by parts formula to reduce this x to cube power to x to 0 power. So let me put again f of x equals x cube. F prime of x will be equal 3x squared, and what left? E to power 2x. So our g prime must be equal e to power 2x. Antiderivative of e to power 2x is equal 1 over 2 e to power 2x. So now we can rewrite our beginning. We have 1/2 x to fourth power e to power 2x minus 2, and now in brackets we have to again use this formula. F times g first, f times g, so we have x cubed times 1/2 e to power 2x minus we have, and we have now integral of f prime is 3x squared times g is 1/2 e to power 2x with respect to x. Close brackets. This is equal. Beginning we have to rewrite. We have 1/2 x to fourth power e to power 2x, and we have negative 2 times 1/2 will reduce, so we'll have negative 1. You don't have to write, just x cube e to power 2x. Negative times negative give us positive, and we have 2 times this integral, because we have here 1/2, so again 2 we can reduce, so what left? We have 3. We will put before integral, and we have integral of x squared times e to power 2x with respect to x. We see our integral become simpler. We have now x squared e to power 2x. At the beginning we have x to fourth power. So again we will use integration by part formula. F of x we will put equals x squared, so f prime of x is equal to x. What left? E to power 2x, so we will put g prime, we have to put g prime of x is equal e to power 2x. Antiderivative of g prime is 1/2 e to power 2x. So now again we have to copy beginning. We have 1/2 x to fourth power e to power 2x minus x cubed e to power 2x plus 3, and in brackets first we have to put f times g. So now we have x squared times 1/2 e to power 2x minus, and now we have integral of f prime is 2x times g. G is 1/2 e to power 2x with respect to x. So this is equal to, and 2 we can reduce. The beginning we need to copy, so we have 1 over 2x to fourth power e to power 2x minus x cubed e to power 2x plus, and we will have 3 times 1/2 is 3 over 2x squared e to power 2x. 3 times negative 1 is negative 3 integral of x e to power 2x dx. And again we see that the power of x is now 1. At the beginning we have 4. So we will use integration by parts one more time. Let's put again f of x equals xy, because now f prime is 1. So now we have what left. G prime of x is equal our e to power 2x. Antiderivative will be equal 1 over 2 e to power 2x. So this is equal, we have to copy the beginning, 1/2 x to 4th power e to power 2x minus x cube e to power 2x plus 3 over 2 x squared e to power 2x minus will be 3, and in brackets we will put first, again we will use this formula, first f times g, so now f is equal x times 1/2 e to power 2x, and we have minus integral of f prime is 1, and we have g is 1/2 e to power 2x with respect to x, close brackets. So this is equal. We have 1/2 x to 4th power e to power 2x minus x cube e to power 2x plus 3 over 2 x squared e to power 2x minus will be 3 times 1/2 is 3 over 2 x e to power 2x, and now we have negative times negative give us positive, and we will take this 1/2 before integral times 3 will be 3 over 2, and we have integral of e to power 2x with respect to x. This is equal. We have 1/2 x to 4th power e to power 2x minus x cube e to power 2x plus 3 over 2x squared e to power 2x minus 3 over 2x e to power 2x plus we have 3 over 2, and integral of e to power 2x is 1/2 e to power 2x. Of course, we need to add constant c. So this is equal. Now we can factorize e to power 2x, and in parentheses we will have 1/2 x to 4th power minus x cube plus 3 over 2x squared minus 3 over 2x plus 3 times 1 is 3, 2 times 2 is 4, close parenthesis, plus c. This is my solution. We have integral of product. We have e to power x times cosine of 2/3 times x. Let me rewrite this. We have integral of e to power x times cosine of 2/3 x with respect to x. So because we have multiplication, we can use formula for integration by parts. Let me remind you this formula when we have integral of f of x times g prime of x dx. This is equal f of x times g of x minus integral of f prime of x g of x dx. Because when we take derivative of e to power x, it still will be e to power x, so I will put for f of x cosine. F of x is equal cosine of 2 over 3 x. So f prime of x is equal, derivative of cosine is negative sine, we have 2/3 of x, and derivative of function which is inside, derivative of 2/3 times x is 2/3. So I will put this before sine. We have negative 2/3 times sine of 2/3x. So now whatever left in our integrand, so this is e to power x, is our g prime. G prime of x is equal e to power x. So our antiderivative is e to power x, because derivative of e to power x is e to power x. Now we can rewrite our integral of e to power x times cosine of 2/3x with respect to x to this form. So will be f times g. So first I will put e to power x times cosine of 2/3x minus integral of f prime is negative 2/3 sine of 2/3x times g. G is e to power x with respect to x. So this is equal. Now let me rewrite this. This is equal e to power x cosine of 2/3x. Negative and negative give us positive. And we will put the constant before integral. So we have 2/3 integral of, first I will put e to power x sine of 2/3x with respect to x. So this is equal. Again, I will use integration by parts formula. Now I will put for f of x sine of 2/3x. So f prime of x is equal, derivative of sine is cosine of 2/3x, and derivative of function which is inside, derivative of 2/3 times x is 2/3. So I will put this before cosine. Whatever left, we have e to power x is our g prime of x. So antiderivative will be e to power x. And again, we will use this formula. The beginning we have to copy, so we have e to power x cosine of 2/3x plus 2/3, and now in brackets we will put first f times g. So I will put e to power x first. Next we have sine of 2/3x minus, and we have integral of f prime is 2/3 cosine of 2/3x times g. G is e to power x with respect to x. So this is equal. Let me rewrite this. We have e to power x cosine of 2/3x plus, we can do multiplication, so it will be 2/3 times e to power x sine of 2/3 of x minus will be, we have to multiply 2/3 times 2/3, so will be 4/9, and we have integral of cosine of 2/3x e to power x dx. What we have here, let's look. At the beginning we have integral of e to power x cosine 2/3x dx with respect to x. We got the same integrand. So let me rewrite one more time. We have at the beginning integral of e to power x times cosine of 2 over 3 x dx is equal, we have e to power x cosine of 2 over 3x plus 2 over 3 e to power x sine of 2 over 3 x, and we have minus 4 over 9 integral. I will put first e to power x cosine of 2 over 3x with respect to x. Because we have the same integrand, I will move negative integral to the left side. So now we will have integral of e to power x cosine of 2 over 3x. We have negative, so it will be positive 4 over 9 integral of e to power x cosine of 2 over 3x with respect to x. This is equal. We can factorize e to power x, so will be e to power x, and in parentheses we will have cosine of 2 over 3x plus 2 over 3 sine of 2 over 3x. Because we have the same integral, here is just one integral plus 4 over 9 integrals. So we can add this one and 4 over 9. So the same denominator will be 9. 9 plus 4 is 13 over 9. And we have integral of e to power x cosine of 2 over 3x with respect to x. I forgot dx here. So this is equal. We have e to power x cosine of 2 over 3 x plus 2 over 3 times sine of 2 over 3 of x. So now, because we need to find integral of e to power x times cosine of 2 over 3x with respect to x, I will multiply both sides by 9 over 13 to reduce this fraction. So we can reduce, and we have integral of e to power x cosine of 2 over 3x with respect to x is equal 9 over 13 e to power x, and in parentheses we have cosine of 2 over 3x plus 2 over 3 sine of 2 over 3x. This is my solution. First I will rewrite our integral, and I will change square root to power form. So this is equal integral of x to power 1/2 natural logarithm of x with respect to x. Of course, x must be greater than 0 because we calculate logarithm only for positive values. We have multiplication here, and when I take derivative of natural logarithm of x, I will have 1 over x, so I will reduce our natural logarithm here. When we use integration by parts formula, I will put for f of x natural logarithm of x. And now derivative of f will be 1 over x. What left? Our x to 1/2 power. This is our g prime. And now we need to find antiderivative. So this is equal to 1/3 x to power 3 over 2. Let me remind you formula for integration by parts. When we have integral of product f of x times g prime of x with respect to x, this is equal f of x times g of x minus integral of f prime of x times g of x with respect to x. So now we have to just use this formula. We have f, we have g, we have f prime. So our integral of x to power 1/2 times natural logarithm of x with respect to x will be equal. We have f times g, so it will be, I will put this fraction first, so it will be 2/3 x to power 3/2 times natural logarithm of x minus, we have integral of f prime is 1/x, g is equal 2/3 times x to power 3/2 with respect to x. This is equal. We have to copy first expression. We have 2/3 x to power 3/2 natural logarithm of x minus, and now we will change 1/x to negative power, so it will be x to -1, and constant I will put before integral symbol. So we have x to -1 times x to power 3/2 with respect to x. This is equal. We have to copy beginning 2/3 x to power 3/2 natural logarithm of x minus, we have 2/3, and we have integral. We have the same base, so we need to add exponent. 3/2 plus -1 is x to power 1/2 with respect to x. Now we have to use integral of power function formula to find integral of x to power 1/2. So we have 2/3 and x to power 3/2, we can write that this is x times square of x, natural logarithm of x minus 2/3 we have to copy, and integral of x to power 1/2 is x to power 1/2 plus 1 over 1/2 plus 1. Of course, we need to add constant, so this is equal. We have 2/3 times x times square root of x, natural logarithm of x minus 2/3, and we will have in denominator 3/2, so we have to flip this fraction, so it will be times 2/3, and x will be to power 3/2 plus c. Now what we can do, we will change x to power 3/2 to x times square root of x, and we can factorize. Let me do step by step. So first I will copy one more times 2/3 x times square root of x, natural logarithm of x minus, and because we have 2/3 at the beginning, so I will not do multiplication, so it will be 2/3 times 2/3, and x to power 3/2 will be x times square root of x plus constant c. Now we can factorize 2/3 times x square root of x, and in brackets we will have natural logarithm of x minus 2/3 plus constant c. This is my solution. Because we need to use formula for integration by parts, so we need product here. Let me rewrite our integral, and I will put natural logarithm of absolute value of x cube times 1 dx. We have product. And first, let me remind you formula for integration by parts. When we have integral of f of x times g prime of x with respect to x, this is equal f of x g of x minus integral of f prime of x times g of x with respect to x. Because we need to reduce this power, I will put that f of x is equal natural logarithm of absolute value of x cube. So now when we take derivative of f, we will reduce our exponent. Will be 3 times natural logarithm of absolute value of x to square, and times derivative of function which is inside. Derivative of natural logarithm of absolute value of x is 1 over x. Next, whatever left is our g prime. We put that natural logarithm of absolute value of x cube is f, so our g prime of x is equal 1. So our antiderivative is equal x. So now we can go to our formula and just replace. So let me rewrite our integral. Cube of natural logarithm of x, absolute value of x, dx is equal f times g. So I will put first x times cube of natural logarithm of absolute value of x minus integral of, now we have to put first f prime. F prime is 3 times natural logarithm of absolute value square times 1 over x times g. G is equal x. dx. X and x we can reduce, and we have that this is equal x times cube of natural logarithm of absolute value of x minus, we can take 3 before integral, and we have square of natural logarithm of absolute value of x with respect to x. We see that our exponent at the beginning was 3 and now is 2. So we can use one more times integration by parts formula. Again, I will put f of x is equal square of natural logarithm of absolute value of x. So f prime of x is equal 2 times natural logarithm of absolute value of x, and the derivative of function which is inside is 1 over x. Whatever left is our g prime. We have to just write this times 1, like at the beginning we have. This 1 is our g prime. So g is equal x. So now we have to just replace one more time. The beginning we have to copy. So we have x times cube of natural logarithm of absolute value of x minus 3, and we have times integral. We will open brackets and we will have first f times g. So first I will put x times square root of natural logarithm of absolute value of x minus, we have, and now we have integral of f prime. F prime is 2 times natural logarithm of absolute value of x times 1 over x times g. G is equal x dx. Again, x and x we can reduce, and we have x times cube of natural logarithm of absolute value of x minus, I forgot close brackets, we have to multiply by negative 3 every expression in brackets. So negative times positive will be negative 3x, and we have natural logarithm of absolute value of x square minus, and negative give us positive. 3 times 2 will be 6. and we have integral of natural logarithm of absolute value of x with respect to x. So this is equal, we have to copy beginning x times cube of natural logarithm of absolute value of x minus 3 times x times square of natural logarithm of absolute value of x plus, and we have 6, and integral of natural logarithm of absolute value of x we have here. So again we have to use integration by parts formula. Again we will put f of x is equal natural logarithm of absolute value of x. F prime of x is equal 1 over x. G prime of x is equal 1. So g is equal x. So we will have 6 times, we will have to open brackets, and first we have to put f times g. So we have x times natural logarithm of absolute value of x, and we have minus integral of f prime is 1 over x times g x with respect to x. So this is equal, we have x times cube of natural logarithm of absolute value of x minus 3 times x times natural logarithm of absolute value of x square plus, and now we have to multiply every expression in brackets by 6. So we have 6 times x natural logarithm of absolute value of x. Positive and negative will be negative, and we have 6 times 1 is 6, and x we can reduce, and integral of 1 is x. Of course we need to add constant. This is my solution. We have integral of x to power n times natural logarithm of x. So first, what we need to put, that x must be greater than 0. We calculate only logarithm of positive values. Next, because we have multiplication here, and we have natural logarithm of x, so it will be very easy to reduce natural logarithm of x when we put that f of x is equal natural logarithm of x. Why I did this? Because we need to use here integration by parts formula. Let me remind you this formula. When we have integral of f of x times g prime of x with respect to x, this is equal f of x times g of x minus integral of f prime of x g of x with respect to x. So now when we have f, we have to find f prime of x. This is equal 1 over x. Next, whatever left is our g prime. So we have g prime of x is equal x to power n. So antiderivative will be equal x to power n plus 1 over n plus 1. So now we have to just use this formula. We have, let me rewrite our example. We have integral of x to power n times natural logarithm of x with respect to x. This is equal, first we have to multiply f times g. So f is equal natural logarithm of x, and we have g, this is x to power n plus 1 over n plus 1. Next we have negative sign, and we have integral of f prime is 1 over x times g is, we can write that this is x to power n plus 1 times 1 over n plus 1. n plus 1 is constant with respect to x. So this is equal, I will put first x to power n plus 1 over n plus 1 times natural logarithm of x, and we have negative sign. Because we have 1 over x, we can change this to power 4, so it will be x to power negative 1 times we have x to power n plus 1, and 1 over n plus 1 is constant, so we can put before integral symbol 1 over n plus 1. We have integral with respect to x. Now we have here multiplication and we have the same base, so we will add exponent. Let me copy beginning, x to power n plus 1 over n plus 1 natural logarithm of x minus 1 over n plus 1, and we will have integral of x to power negative 1 plus n plus 1. This is n with respect to x. So this is equal, we have x to power n plus 1 over n plus 1 natural logarithm of x minus 1 over n plus 1 integral of power function. So we will use formula that this is equal times x to power n plus 1 over n plus 1 plus constant c, of course. So this is equal, we can factorize x to power n plus 1 over n plus 1. In parentheses we will have natural logarithm of x minus 1 over n plus 1 plus constant c. This is my solution. Let me remind you first formula for integration by parts. When we have integral of f of x times g prime of x with respect to x, this is equal f of x times g of x minus integral of f prime of x times g of x with respect to x. So here we have division. So first I will change this to product. So this is equal. First we will have integral of natural logarithm of absolute value of x to second power, and we have x to fifth power in denominator. So we can put that this is equal times x to negative power 5 with respect to x. Now we have multiplication, and to reduce this natural logarithm I will put that f of x is equal square of natural logarithm of absolute value of x. So f prime of x will be 2 times natural logarithm of absolute value of x and derivative of function which is inside. Derivative of natural logarithm of absolute value of x is 1 over x. Now whatever left is our g prime. F of x is this first expression, so we have g prime of x is equal x to power negative 5. Now we need to find g of x. This is equal negative 1 over 4 times x to negative 4. Let's check. When we take derivative of this function, it will be negative 1, 4, we have to just copy, and derivative of x to power negative 4, we have to take this negative 4 down, so it will be negative 1 over 4 times negative 4, give us positive 1, so here is positive 1, invisible, and x will be to power negative 4 minus 1, so will be negative 5, so everything is okay. Now we have to just use this formula. We can write that our integral is equal. First we have to put f times g, so will be, I will put first this negative 1 over 4 x to power negative 4 times square of natural logarithm of absolute value of x minus, and now we have integral of f prime is equal to natural logarithm of absolute value of x times 1 over x times g. G is equal negative 1 over 4 x to power negative 4 with respect to x. So this is equal 4 we can reduce with 2, and we will have to copy negative 1 over 4. We have power x to negative 4, so we can put this in the numerator, times square of natural logarithm of absolute value of x square minus negative times negative give us positive, and we have here constant 1 over 2 times integral of natural logarithm of absolute value of x, and we have here 1 over x. 1 over x is equal x to negative 1 power. So we have x to negative 1 power times x to negative 4. So it will be x to power negative fifth with respect to x. So this is equal, again, because we have now natural logarithm of absolute value of x times x to negative fifth power. To reduce this natural logarithm, I will put that f of x is equal natural logarithm of absolute value of x. So f prime of x is equal 1 over x. Whatever left is our g prime of x is equal x to negative fifth power. So our g is equal negative 1 over 4 x to power negative 4. One more time we will use formula for integration by parts. So now we have to multiply first f times f times g, but before we do this, first we have to copy beginning. So we have negative 1 over 4x to 4th power times square root of natural logarithm of absolute value of x, and we have plus 1/2, and now we have to open brackets. First we have to put f times g. So we have, I will put first this expression, so it will be negative 1 over 4, because we have negative power 4, so I will put this x to the numerator, and we have times natural logarithm of absolute value of x, and now we have minus integral, I just use this formula, minus integral of f prime times g. F prime is 1 over x times g, so times negative 1 over 4 x to power negative 4. With respect to x, we have integral. So this is equal, we have to close brackets. So we have negative 1 over 4x to 4th power, square of natural logarithm of absolute value of x, and we have positive times negative will be negative, will be 1 over 8x to 4th power, natural logarithm of absolute value of x. First, negative times negative give us positive, positive times positive will be positive, and we have 1/2 times 1 over 4 is 1 over 8, and we have integral, again 1 over x is x to power negative 1 times x to power negative 4 is x to power negative fifth with respect to x. So this is equal. Now we have to just use integral of power function formula to calculate this integral. So this is equal. We have negative 1 over 4x to 4th power, and we have square of natural logarithm of absolute value of x minus 1 over 8 x to 4th power natural logarithm of absolute value of x plus we have 1 over 8, and now integral of x to negative 5th power will be x to power negative 4 over negative 4 plus constant c. So this is equal. We have to rewrite this one more time. We have negative 1 over 4x to 4th power times square of natural logarithm of absolute value of x minus 1 over 8x to 4th power natural logarithm of absolute value of x, and positive times negative is negative 1 over 32, and we have x to 4th power plus c. So this is equal. We can factorize negative 1 over 32x to 4th power. So in brackets we will have first, because we have negative sign, so here will be positive 8 times natural logarithm of absolute value of x square, and now we have to put here plus again because we have negative here sign, so it will be 4 times natural logarithm of absolute value of x, and again we have plus 1 close bracket plus constant c. This is my solution. We have to use formula for integration by parts. So let me remind this formula first. We have integral of f of x times g prime of x with respect to x. This is equal f of x times g of x minus we have integral of f prime of x times g of x with respect to x. So we need here multiplication. So I will rewrite our square root to power form. So this is equal integral of and natural logarithm of x to square. I will just copy. So natural logarithm of x square, and like I said, I change to power form, so it will be x to power 1/2, and because we have this expression in denominator, we have to add negative sign before the exponent. With respect to x, we have integral. Of course, x must be greater than 0. Next, I will put, because we have natural logarithm here, to reduce natural logarithm, we need to put that f of x is equal natural logarithm of x to 2nd power. Now, when we take derivative of f, we will have 2 times natural logarithm of x, and derivative of natural logarithm of x is 1 over x. So now, when I put that f of x is equal square of natural logarithm of x, the left part must be equal g prime of x. Why? Because we have to use this formula. I put for f square of natural logarithm of x, so lever left, in this case, in this example, we have x to negative 1/2 power must be equal g prime. So our g is equal, it will be 2x to power 1/2. When you take derivative of this function, we will get exactly the same expression. So now we have to do substitution to this formula. First we have f times g. So we will have, first I will put this function 2 times x to power 1/2 square of natural logarithm of x, and we have negative sign. Integral of f prime is 2 times natural logarithm of x times 1 over x and times g. G is equal 2 times x to power 1/2 with respect to x. So this is equal. We have to copy 2 x to 1/2 power, so it's square root of x times natural logarithm of x square minus, and we have 2 times 2 will be 4. We can put before integral, and now we have integral of natural logarithm of x. We need to copy, and we have 1 over x. 1 over x is x to negative 1 power. So we have the same base, x and x, so we need to add exponent. Negative 1 plus 1/2 will be x to power negative 1/2. And we have integral with respect to x. So now, to reduce this natural logarithm of x, we need to do one more time integration by parts. Again, I will put f of x is equal natural logarithm of x. So f prime of x will be 1 over x. So whatever left must be our g prime. G prime is x to power negative 1/2. So g is equal 2 times x to power 1/2. So now g, of course, of x. Now we have to again use this formula. The beginning we need to copy, so this is equal 2 times square root of x times natural logarithm of x to second power minus, and we have 4, and in brackets we will put first f we have times g, so it will be, I will put first 2x, we have to 1/2 power, so I can put 2x squared times natural logarithm of x minus, and we have integral of f prime is 1 over x times g is 2 times x to power 1/2 dx. Close brackets, this is equal. We have to copy 2 square root of x square of natural logarithm of x minus, and we have 4 times 2 will be 8 square root of x natural logarithm of x. Negative and negative give us positive, and we will have 4 times 2 is 8, and we will have integral of, one more times, 1 over x is equal x to negative 1, so we have the same base, we need to add exponents, so it will be x to power negative 1/2 with respect to x. We have integral, so this is equal. We have to rewrite 2 square root of x natural logarithm of x to second power, of course, minus 8 square root of x natural logarithm of x plus 8, and now we have to use integral of power function formula, so it will be times x to power negative 1/2 plus 1, so will be 1/2 over 1/2. Always exponent is the same like denominator, plus constant c, of course. So this is equal. We have 2 square root of x natural logarithm of x to second power minus 8 square root of x natural logarithm of x. We have to flip this number, so it will be 8 times 2 is 16, x to 1/2 power is square root of x, I forgot to put plus constant c. We can factorize now 2 square root of x, and in parentheses we will have, I will put brackets because we need to put natural logarithm of x to second power, and we have minus 4 natural logarithm of x plus will be 8 close brackets plus c. This is my solution. We need to use formula for integration by parts. So first let me remind you this formula. When we have integral of f of x times g prime of x with respect to x, this is equal f of x times g of x minus integral of f prime of x times g of x with respect to x. So we need here multiplication. We have only cosine cube. So I will rewrite first our cosine cube to cosine square of x times cosine of x with respect to x. Now we have multiplication. To reduce this power, I will put that f of x is equal cosine square of x. So now when I take derivative, we will have f prime of x is equal 2 times cosine of x, and derivative of cosine is negative sine. So I will put this negative before 2 sine of x. Whatever left is our g prime, because we need this formula. We just put that f of x is equal x squared, so cosine x is left. This is our g prime. So now our g is equal sine of x. You can always check when you take derivative of sine is cosine. Exactly the same expression. So now we have to just substitute to our formula. We have this is equal. First we have f times g, so it will be cosine square of x times sine of x minus integral of f prime is negative 2 cosine of x sine of x times g. G is equal sine of x, and with respect to x, this is equal. We can rewrite this. This is cosine square of x sine of x. Negative and negative give us positive. We can put constant before integral, and we have cosine of x. Sine times sine is sine square of x with respect to x. So now I will use substitution method, and I will put that sine of x is equal u. Let me write this. We have u is equal sine of x. So du to dx is equal cosine of x. Now to find du, because when we do u substitution, we need to find du. We need to multiply both sides by dx. Dx and dx we can reduce, and we have that du is equal cosine dx. So now first we will solve this integral. Let me rewrite this here. We have integral, and I will put first sine square of x times cosine of x with respect to x. So this is equal. For sine, we have to put just u. So we have integral of u to second power because we have sine square. And cosine dx is equal du. So this is equal. We need to use integral of power function formula. So this is equal u to third power over 3 plus, of course, constant c when we have indefinite integral. So now we have to come back to our substitution. U is equal sine of x, so this is equal, I can put first 1/3 times sine to third power of x plus c. So our integral, we will put now here, this is equal, the beginning we need to copy, we have cosine of 2x sine of x plus 2, and this part we have to just replace by 1/3 sine cube of x plus constant c. So this is equal. We have cosine square here. We know that sine square of x plus cosine square of x is equal 1. So cosine square of x will be equal 1 minus sine square of x. So now we can replace cosine square of x by 1 minus sine square of x. So this is equal, in parentheses we will have 1 minus sine of square of x times sine of x, and we have 2 times 1/3 is 2/3 sine cube of x. 2 times constant is still constant, so we can put c1. So this is equal, we have 1 times sine of x is sine of x, negative sine square of x times sine of x will be negative sine cube of x plus 2/3 sine cube of x plus c1. This is equal, sine of x we need to copy, and we have like negative 1 sine cube of x plus 2/3, so will be negative 1/3 sine cube of x plus constant c1. This is my solution. We need to use formula for integration by parts. So first let me remind you this formula when we have integral of f of x times g prime of x with respect to x. This is equal f of x times g of x minus integral of f prime of x times g of x with respect to x. So first what I do here, I will change tangent. We know that 1 plus tangent square of r is equal secant square of r. So our tangent square of r is equal secant square of r minus 1. So we will replace our tangent by secant square minus 1. So let me rewrite this. We have integral of r times secant square of r minus 1 with respect to r. So this is equal. We can do multiplication, so it will be integral of r times secant square of r minus r. Have integral with respect to r. So we have integral of difference, so we can rewrite that this is equal difference of integrals, integral of r secant square of r with respect to r minus integral of r with respect to r. So this is equal. The second integral is very easy to solve. What we need to do? We have to solve only integral of r times secant square of r. To solve this integral, we will use integration by parts formula to solve this integral. Let me put that f of r is equal r. So f prime of r will be equal 1. Now if I put that this is our f, so our g prime must be equal secant square. G prime of r is equal secant square of r. So our g of r is equal tangent r. The root of tangent is secant square. So now, first we will solve this integral. So this is equal. We have to first multiply f times g. So we have r times tangent r minus, and next we have integral of f prime is 1 times g. G is tangent r with respect to r, minus, and integral of power function formula we need to use. The power is 1, invisible 1, so we have r to power 2 over 2 plus constant c, of course. So this is equal. We have r times tangent r minus integral of tangent r. 1 times tangent is tangent dr, minus we have 1/2 r square plus constant c. So this is equal. We have r times tangent r minus integral of tangent is negative natural logarithm of absolute value of cosine of x. And we have minus 1/2 r square plus c. Of course, we need to add c here, but c and c will be still the constant, so I can put here c1. So this is equal. We have r tangent r, negative and negative give us positive natural logarithm of absolute value of cosine of x minus 1/2 r square plus c1. This is my solution. First, let me remind you formula for integration by parts. When we have integral of f of x times g prime of x with respect to x, this is equal f of x times g of x minus integral of f prime of x times g of x with respect to x. So, because we have multiplication here, I will put that f of x is equal f of t. We have with respect to t, f of t is equal natural logarithm of t. Why I put natural logarithm of t for f of t? Because when I take derivative, I will reduce this natural logarithm. And of course, because we have natural logarithm, t must be greater than 0. So next, f prime of t is equal 1 over t. So because natural logarithm of t, I just put that this is equal f of t. Whatever left is our g prime of t. So this is our t to power 5th. So g of t is equal 1 over 6 t to power 6. So now we have to just substitute to our formula. Our integral of t to 5th power natural logarithm of t with respect to t is equal f times g first. So first I will put 1 over 6 t to power 6 natural logarithm of t minus integral, we have f prime is 1 over t times g. G is equal 1 over 6 t to power 6 with respect to t. So this is equal. We can copy beginning, so we have 1 over 6 t to power 6 natural logarithm of t, and we have minus, constant we can take before integral, and 1 over t is equal t to power negative 1. The same base we have, so we have to add exponent, will be t to power fifth dt. So this is equal, we have to copy 1 over 6 t to power 6 natural logarithm of t minus we have 1 over 6 and integral of power function we have to calculate, so this is equal t to power 6 over 6 plus of course constant c. So this is equal, we can factorize 1 over 6 times t to power 6 and in brackets we will put natural logarithm of t minus 1 over 6 plus constant c. This is my solution. We have definite integral, so first we have to check if our function is continuous. Our denominator we have square root of 4 plus x squared. This number is always positive. So our function we can say is continuous. So now to solve definite integral, first we need to solve this integral like indefinite integral. So to do this we will use substitution method. First let me change the square root to power 4. So this is equal, we have definite integral from 0 to 1 and we will have x cubed times 4 plus x squared to power negative 1/2 dx. Now we will put that 4 plus x squared is equal u. Now we have to take derivative of both sides of our equation, so we have 2x is equal du to dx. Now we will multiply both sides of our equation by dx because we need to find du when we do u substitution. So now we have du is equal to x dx. I just changed the sides, but here we don't have 2. We have x cubed only dx. So what I can do here? First, I will rewrite our definite integral and change x cubed to x squared times x. So I can put first x squared and next will be 4 plus x squared to power negative 1/2 and next I will put x dx. We found that du is equal to x dx. Now I will divide both sides by 2. 2 and 2 we can reduce and we have that x dx is equal 1/2 du. So we have x dx, we have 4 plus x squared equals u. We need to find x squared. So x squared I will find from this equation. X squared will be equal u minus 4. Now we can substitute. We have to copy integral symbol. X squared is equal u minus 4. Let me put this in parentheses. We have u minus 4. Next we have 4 plus x squared equals u. So it will be u to power negative 1/2 and x dx is equal 1/2 du. So this is equal, I can put first constant before integral symbol and we have integral from 0 to 1 of u minus 4 times u to power negative 1/2 du. This is equal, I can do multiplication here. So we will have 1/2 integral from 0 to 1 of u times u to power negative 1/2 minus, let me put this in parentheses, negative 4 times u to negative 1/2 du. So this is equal we have to copy 1 over 2, and we have integral of difference, so this is equal difference of integrals. And what else? We can do multiplication here. Because we have here the same base, we can add exponent. Here we have invisible 1, so we can rewrite this integral one more time. We have integral from 0 to 1 of u to power will be 1 plus negative 1/2 is 1/2 with respect to u. Let me put this in brackets because we have 1/2 at the beginning of this integral, and minus we have integral from 0 to 1 of 4u to power negative 1/2 du. Close brackets. This is equal. We have to copy 1/2, and in brackets we will have integral of power function is equal u to power 1/2 plus 1 over 1/2 plus 1. We have definite integral, so we need to put vertical bar. On the top we have upper limit 1, on the bottom we have lower limit 0, minus, and now we have to copy first 4, and again we have to use integral of power function formula. So we will have 4 times u to power negative 1/2 plus 1 over negative 1/2 plus 1. And we have limits from 0 to 1. This is equal. We have to close the brackets. So this is equal. We have 1/2, and in brackets we will have 1/2 plus 1 is 3 over 2, so it will be 2 over 3 times u to power 3 over 2, and we have limits from 0 to 1 minus we have 4 times will be negative 1/2 plus 1 is 1/2, so will be times 2, and we have u to power 1/2 limits from 0 to 1. So this is equal. Now we can multiply by 1/2, so we will have 1/2 times 2 over 3, and we have square root of u to third power limits from 0 to 1 minus 1/2 times 8 square root of u limits from 0 to 1. This is equal. 2 and 2 we can reduce, so we have 1/3. We have square root of u to third power, so it will be u times square root of u limits from 0 to 1 minus 4 times square root of u, and we have limits from 0 to 1. Because both expression has limits 0 to 1, I can put first that we have 1/3 u square root of u minus 4 square root of u, and we have limits from 0 to 1. At the beginning, when I write substitution for 4 plus x squared u, I didn't change the limits. We have definite integral. So now I have to come back to our substitution before I plug limits. So this is equal. And what else we can do? We can factorize 1/3 times square root of u. So it will be 1/3 square root of u, and in parentheses we will have u minus 12 and limits from 0 to 1. Now I come back to our substitution. We have 1/3 u is equal 4 plus x squared. So we have square root of 4 plus x squared, and in parentheses we have 4 plus x squared for u minus 12. We have to subtract limits from 0 to 1. So this is equal, and we have 1/3 square root of 4 plus x squared, and in parentheses we will have x squared minus 8, limits from 0 to 1. Now we can plug first upper limit, so will be 1/3 square root of 4 plus 1 power, and in parentheses we have 1 square minus 8, and we have to subtract lower limit, so will be minus 1/3 square root of 4 plus 0 square, and in parentheses will be 0 square minus 8. So this is equal. We have 1/3 square root of 5, and we have 1 minus 8 is negative 7, minus 1/3, and we will have square root of 4. Square root of 4 is 2, so it will be times 2, and we will have negative 8 in parentheses. So this is equal. Positive times negative will be negative, so we have negative 7 square root of 5 over 3 we can write. Negative times negative is positive, so will be plus. 2 times 8 is 16, will be over 3. I can change now and I will put first positive number. We have the same denominator, so we can put 3 in denominator and will be 16 minus 7 square root of 5. This is my solution. We have definite integral. So when we have definite integral, first step, what we have to do? We have to check if our function is continuous. So we need to check the domain of our function first, because we have here in the denominator 1 plus r, we cannot have 0 in the denominator, so r must be different than negative 1. Next, because we need to do integration by parts, let me remind you formula. When we have definite integral from a to b of f of r, because in this case we have integral with respect to r, times g prime of r dr, this is equal f of r times g of r, and next we have to put vertical bar. On the top we have upper limit b, and on the bottom we have lower limit a, minus, and we have definite integral from a to b of f prime of r times g of r with respect to r. Function f and g prime must be continuous. So first let me rewrite this expression to multiplication, because we need to have multiplication to use this formula. We have definite integral from 0 to 2, and we can rewrite this, that this is equal r times e to power r, and we will take this whole expression in parentheses to numerator, so it will be times 1 plus r to power, we need to put negative sign before 2, and we have integral with respect to r. We have r times er, this is continuous function, and our function 1 plus r to power negative 2 is continuous without r equals negative 1. Only for r equals negative 1 our function is discontinuous. But we have here interval from 0 to 2, so everything is okay, because negative 1 is not included. So now let me put that our f of r function is equal r e to power r. So next step, we need to find f prime of r. We need to have product rule to find derivative of this expression. So first we need to find derivative of r is 1 times e to power r plus, and next we have to copy first expression times derivative of e to power r is e to power r. What we can do here, we can factorize e to power r, so we will have f prime of r is equal e to power r, and in parentheses we will have 1 plus r. We have f prime. Now whatever left is our g prime. So this is equal 1 plus r to power negative 2. So we need to find antiderivative. So g of r is equal negative, and in parentheses we have 1 plus r to power negative 1. You can always check if you take derivative of this expression, you will get this. So next we can just substitute to our formula. This is equal. We have f of r times g of r. So we have r times e to power r times, and in brackets we will put negative 1 plus r in parentheses to negative 1 power, and we need to put vertical bar. On the top we have 2 and on the bottom we have 0 because we have definite integral from 0 to 2 minus, and we have to rewrite integral symbol from 0 to 2. F prime is equal e to power r times 1 plus r times g is equal, we'll put in brackets this because we have negative sign, and 1 plus r to power negative 1 with respect to r. So this is equal. First we will simplify it a little. So we have here positive times negative, so will be negative, and we have r times e to power r, and in parentheses we will have 1 plus r to power negative 1, and we have limits from 0 to 2 minus, and because we have negative and negative, so we have to change the sign to positive. We have integral from 0 to 2 e to power r times, and we have this minus we don't have now. We change this to plus. So now we have the same base. When we have the same base, we have to add exponent. Here we have invisible 1. So 1 plus negative 1 is 0. So we have 1 plus r to power 0 with respect to r. This is equal. Let me rewrite first expression. We have negative r e to power r, and because we have negative exponent 1 here, we can put this expression in parentheses to denominator. To first power we don't need to write. We have limits from 0 to 2 plus, and now when we take to power 0, 1 plus r, it will be 1. So we have integral from 0 to 2 of e to power r only with respect to r. So this is equal. We will have to copy one more time first expression. Limits from 0 to 2, and we have plus. We have integral of e to power r is e to power r, and we have vertical bar, limits on the top 2, on the bottom 0, be negative sign. We have to plug first upper limit. We have to substitute r's by 2. So we have negative will be 2 times e to power 2 over 1 plus 2. And we need to subtract the lower limit, so we have minus, and we will put this in brackets because we have negative sign. So we have negative, and now we substitute r's by 0. So we have 0 times e to power 0 over 1 plus 0 plus, and now we need to substitute first upper limit for r. So we have e to power 2 minus lower limit is 0. So we have e to power 0. This is equal. We will have negative 2 times e to power 2 over 3. This expression will be 0 because 0 times whatever we have here will be 0. So now we have to put plus e to power 2, and we have minus e to power 0 is 1. So this is equal. We can factorize e to power 2. In parentheses we will have negative 2/3 plus 1, and we have negative 1. So this is equal e to power 2 times negative 2/3 plus 1 will be 1/3. So we can put in front 1/3 e to second power minus 1. Now you can use calculator and find this value. We have 1 over 3 times e to second power minus 1. So this is equal 1.46. This is my solution. We have definite integral and we need to integrate by parts. So first let me remind you formula for integration by parts. We have definite integral a to b. We have product of f of s, because in this case we have integral with respect to s, times g prime of s with respect to s. This is equal f of s times g of s, and we need to put vertical bar, and on the top we have upper limit, and on the bottom we have lower limit a, minus integral from a to b of f prime of s times g of s with respect to s. So now what we need to check? We need to check if our function f and g prime is continuous. We have natural logarithm and is continuous. We have square root, but we know that we can calculate square root of positive or equal 0 number. But here we have square root in denominator, so we cannot have 0 in denominator. And we calculate natural logarithm for positive value. So our s plus 1 must be greater than 0. So s must be greater than negative 1. We have here integral from 1 to 3. So we have closed interval from 1 to 3. This interval is included in domain of our function because this is greater than negative 1. We have one interval from 1 to 3. So everything is okay. Our functions are continuous. Next, we have to rewrite our function to product. So let me put this is equal. We have integral from 1 to 3. We will copy numerator, natural logarithm of s plus 1. And we will put, instead of square root, we will put s plus 1 to power 1/2. So we have square root, and we need to put negative sign because we take this square root to numerator. and we have integral with respect to s. Next, let me put that our f of s is equal natural logarithm of s plus 1. Why I put f of s equals natural logarithm? Because it's very easy to find derivative f prime of s, and we will reduce now our logarithm to function. Derivative of natural logarithm of s plus 1 is 1 over s plus 1. And we need to put times derivative of function which is in parentheses. By derivative of s is 1, derivative of 1 is 0, so 1 plus 0 will be 1, so times 1, it doesn't change anything. So this is our derivative. Next we have g prime of s, is whatever we left is s plus 1 to power negative 1/2. Now we need to find antiderivatives, so g of s is equal to times s plus 1 to power 1/2, of course. If you take derivative of this expression, we will get exactly the same what we have here. So next step, we have to just plug this expression to our formula. So this is equal. First, we have f of s times g of s. So we have natural logarithm of s plus 1 times 2 times s plus 1 to power 1/2. And we have to put vertical bar. On the top we have upper limit 3 and on the bottom we have lower limit 1. Minus definite integral from 1 to 3. F prime is equal 1 over s plus 1 times g is equal 2 times s plus 1 to power 1/2 with respect to s. We have integral. So this is equal. Now we can simplify a little. We will change this to square root and put first before natural logarithm. So this is equal to square root of s plus 1 times natural logarithm of s plus 1. We have limits from 1 to 3. And we have minus, because we have here in the limit of s plus 1, it's the same expression which we have here. So we will change, we have integral from 1 to 3, this fraction to power form, so it will be s plus 1 to negative 1 power, and we can take this constant before integral symbol. We have times s plus 1 to power 1/2 with respect to s. So this is equal. First expression you can calculate or just copy. We can calculate this now. It means we have to plug first upper limit. So this is equal to, and we need to substitute s's by 3 first. So we have 3 plus 1 times natural logarithm of 3 plus 1 minus, and now we have to plug lower limit, so we have to replace s's by 1 now. So we have 2 times 1 plus 1 times natural logarithm of 1 plus 1. And we have now minus, we have 2 and definite integral from 1 to 3. We have the same base, so we need to add exponent. So it will be s plus 1 to power negative 1/2 with respect to s. So this is equal. We have 2 times square root of 4 is 2, so it will be 2 times 2 natural logarithm of 4 minus we have 2 times square root of 2 natural logarithm of 2 minus, and now we have to copy 2. To solve this definite integral, we will use substitution method. Let me put this in this right corner. We will put s plus 1 is equal u. So now we have to find the derivative of both sides with respect to s. So derivative of s is 1, derivative of 1 is 0, we don't have to write. And we have du to ds. Now we multiply both sides by ds to reduce this denominator, because we need to find du when we do u substitution. So we have ds is equal du. So we will have integral from 1 to 3 of u to power negative 1/2 with respect to u. I just substitute s plus 1 by u and ds by du. So this is equal. Now we need to use integral of power function formula. So this is equal u to power negative 1/2 plus 1 over negative 1/2 plus 1, and we have limits from 1 to 3. So this is equal. We have in the numerator negative 1/2 plus 1, so it is 1/2. So we will have 2 times u to power 1/2, and we have limits from 1 to 3. Now we have to come back to our substitution 1. Why? Because I didn't change the limits. I substitute s plus 1 by u, but I didn't change the limits 1 and 3. So now we have to come back to the substitution. So this is equal 2. And because we have to power 1/2, so I will have square root of, for u I just put s plus 1. And we have limits from 1 to 3. Now we can plug first upper limit. So we have to copy 2, and we have square root of 3 plus 1 minus, we have to subtract lower limit is 1. It means we have to substitute s by 1 now. So we have 2 times square root of 1 plus 1. This is equal. We can factorize 2, and we will have in parentheses square root of 4 is 2 minus square root of 2. Now we can come back to our problem, and for our integral from 1 to 3 we can just plug this value. So it will be 2 times, we have 2, and in parentheses we have 2 minus square root of 2. This is equal. We have 4 natural logarithm of 4 minus 2 square root of 2 natural logarithm of 2 minus, we have 4 times 2 minus square root of 2. We can use calculator. We have 4 times natural logarithm of 4 minus 2 times square root of 2 times natural logarithm of 2 minus 4, and in parentheses we have 2 minus square root of 2. Close parentheses, this is equal 1.24 we can write. This is my solution. We have to find definite integral by parts. So first let me remind you of this formula. When we have integral from a to b of f of, in this case we have with respect to t, so I will put f of t times g prime of t with respect to t, this is equal f of t times g of t minus And I forgot we have to put limits first from b on the top and on the bottom a minus. Now we have integral from a to b of f prime of t times g of t with respect to t. So what else? Function f g prime must be continuous. So let me rewrite this. We have definite integral from 0 to 1. We can change to multiplication this, so it will be t times e to power negative 2t with respect to t. T is continuous function and e to power negative 2t is continuous too, so everything is okay. Next, we just put that our f of t is equal t. Why I put f of t equals t? Because now when we take derivative of f, we will get just 1. We reduce our t from our expression. And whatever left, so we have g prime of t is equal e to power negative 2t. Now we need to find antiderivative, so g of t is equal negative 1/2 times e to power negative 2t. You can always check when you take derivative of this expression, you should get g prime. So next step, we have to just substitute to our formula. So we have, this is equal f times g, so it will be t times, and in parentheses we will put negative 1/2 e to power negative 2t. We have limits from 0 to 1 minus, and now we have integral from 0 to 1, f prime is equal 1, and g is equal negative 1/2 e to power negative 2t. We have integral with respect to t. So this is equal. We can do some simplification. Positive times negative will be negative. So I will put first negative 1/2 t e to power negative 2t. We have limits from 0 to 1. Negative and negative will be positive. And we have integral from 0 to 1 of, when we multiply by 1, still we will have 1/2 e to power negative 2t. So first I will take this 1/2 before integral, and we have integral only of e to power negative 2t with respect to t. Now let me do this integral first. We have integral from 0 to 1 of e to power negative 2t with respect to t. To do this integral, we will use substitution method. Let me put that u is equal negative 2t. Now we need to find derivative of both sides of our equation. So du is equal to, of course, dt is equal negative 2. So because we need to find du, I will multiply both sides by dt. dt and dt we can reduce, and we have that du is equal negative 2 dt. But we have here only dt, we don't have negative 2. So now I will divide both sides by negative 2. Negative 2 and negative 2 we can reduce, and we have that dt is equal, we can write first negative 1/2 du. So our integral will be equal, we have to copy integral symbol from 0 to 1 e, and instead of negative 2t we have to put u, and for dt we have negative 1/2, we will put in parentheses du. So this is equal. We have to put first constant before integral symbol, so we have negative 1/2 times integral from 0 to 1 of e to power u with respect to u. This is equal. Negative 1/2 we copy, and integral of e to power u is e to power u. Now, because of course we have limits from 0 to 1. And now because I didn't change limits when I do u substitution, I have to come back to t's. So this is equal. We have negative 1/2 e to power negative 2t, and we have limits from 1 to 0. From 0 to 1, of course. So this is equal. Now we have to first plug upper limit. We will have negative 1/2 times e to power will be negative 2 times 1 is negative 2. And we have to subtract lower limit. So we have negative, we will put in parentheses 1/2 times e to power 2, negative 2 times 0 will be 0. So this is equal. We will have negative 1/2 e to power negative 2. Negative and negative give us positive. E to 0 is 1, so we have 1/2 only. So this is our integral from 0 to 1 of e to power negative 2t with respect to t. So now we have to come back to our problem, and we will have this is equal. So now we have to first plug to this expression upper limit instead of t's. So we have negative 1/2 times 1 e to power negative 2 times 1, and we have to subtract lower limit. So this is, I will put in parentheses because we have negative sign before 1/2, will be times 0 e to power negative 2 times 0, close brackets, close parentheses, plus, and we have to copy 1/2. And now, instead this whole integral, we have to just plot this value. So I will put this in brackets. We have negative 1/2 e to power negative 2 plus 1/2. This is equal. What we have here, negative 1/2 e to power negative 2 will be minus, and this whole expression we have 0, so we can reduce. We have now 1/2 times negative 1/2 will be negative 1/4 e to power negative 2. 1/2 times 1/2, so will be plus 1/4. So this is equal. Negative 1/2 and negative 1/4 e to power negative 2. This is negative 3/4 e to power negative 2 plus 1/4. You can factorize 1/4, and you can put first positive expression, so will be 1 minus 3 e to power negative 2. You can leave like this, or you can use calculator and find this value. So we have 1/4 times, and in parentheses we have 1 minus 3 times e to power negative 2, close parentheses. This is equal 0.14. This is my solution. We have definite integral of in parentheses we have y squared plus 1 times e to power negative y. So first I will multiply y squared plus 1 by e to power negative y. So we can rewrite our definite integral from 0 to 1, and we will have y squared times e to power negative y plus 1 times e to power negative y is e to power negative y. We have integral with respect to the y. This is equal. We have integral of sum, so we can rewrite this to sum of integrals. We will have integral from 0 to 1 of y squared e to power negative y with respect to y plus integral from 0 to 1 of e to power negative y with respect to y. We have to solve two integrals. To solve first integral, we will use integration by parts formula. So let me put that our f of y is equal y squared. So f prime of y is equal to y. Whatever left is our g prime. G prime of y is equal e to negative y power. So our antiderivative is equal negative e to power negative y. Now we can come back to our integral, and this is equal. We will have, first we have to put f times g. So we will have y squared times negative e to power negative 1, and we have limits from 0 to 1 minus integral from 0 to 1 f prime is equal to y times g is equal negative e to power negative y dy. So next we have to put plus. We have integral of e to power negative 1 is negative e to power negative y, and we have definite integral, so limits from 0 to 1 we have to write. So this is equal. Positive times negative give us negative. We have y squared e to power negative y, limits from 0 to 1, and we have negative and negative give us positive. 2 we can put before integral symbol, and we have integral from 0 to 1 of y times e to power negative y with respect to y. Positive and negative give us negative e to power negative y, limits from 0 to 1. So this is equal. Now we have to copy everything, and to solve this integral we will use again integration by parts formula. So to solve this integral we will use again this formula. So let me put that now. F of y is equal y, because I want to reduce this y. At the beginning we have y to second power, now we have y to first power, so after this integration we should have y to 0 power. So f prime of y is equal 1. Whatever left is our g prime of y, so is our e to power negative y. Antiderivative of e to power negative y is equal negative e to power negative y. So we have to copy everything. At the beginning we have negative y squared e to power negative y, limits from 0 to 1 we have plus 2, and now we will open brackets and we have to use this formula. So first we have to put f times g, so will be y times negative e to power negative y minus, of course we have to put limits from 0 to 1, minus integral from 0 to 1, and we have to put f prime as 1 times g is equal negative e to power negative y dy, of course, close brackets, and we have minus e to power negative y with limits from 0 to 1. So this is equal, we have negative y squared e to power negative y, limits from 0 to 1, and we have plus 2 times this expression. We can do this multiplication, so it will be positive times negative, so I have to put here minus 2y e to power negative y, and we have limits from 0 to 1. Negative and negative give us positive, and we have times 2 positive, so it will be plus 2 integral from 0 to 1 of e to power negative y with respect to y minus e to power negative y and limits from 0 to 1. So this is equal, we have negative y squared e to power negative y minus, of course, limits from 0 to 1, minus 2 times y e to power negative y, limits from 0 to 1, and we have plus, we have integral of e to power negative y. So we have 2 times negative e to power negative y with limits 0 to 1 minus e to power negative y and limit 0 to 1. So this is equal, because we have the same limits for all this expression, I will put out at the end these limits and start to simplify something. We have negative y squared e to power negative y minus 2y e to power negative y. Positive and negative give us negative 2 e to power negative y minus e to power negative y, and we have limits from 0 to 1. So this is equal, we have to copy beginning, so it will be negative y squared e to power negative y minus 2y e to power negative y, and we have negative 3 e to power negative y, limits from 0 to 1. Now I can factorize negative e to power negative y, and in parentheses we will have y squared plus 2y minus 3, plus 3 of course, because we factorize negative sign, and the limits from 0 to 1. So this is equal. Now we have to plug first upper limit. So it will be negative e to power negative 1, and in parentheses we will have 1 squared plus 2 times 1 plus 3. And we have to subtract lower limit, so it will be minus, and in parentheses we will have negative e to power 0. Let me put this in brackets, and now I will open parentheses, will be 0 squared plus 2 times 0 plus 3, close parentheses and brackets. So this is equal, we will have negative e to power negative 1, and in parentheses we will have 1 plus 2 plus 3, this is equal 6, minus, and now we have negative and negative, so I can put plus. E to 0 is 1, we don't have to write 1, times 3 is 3. So this is equal, we can rewrite this, and first I will put positive number 3 minus 6 e to power negative 1. So this is my solution. We have to integrate by parts. So let me remind formula for integrating by parts for definite integral because we have here definite integral. So when we have definite integral from a to b of f of x times g prime of x with respect to x, this is equal f of x times g of x minus, of course we have to put limits from a to b, minus integral from a to b of f prime of x times g of x with respect to x. So now let me put that f of x is equal e to power x. F prime of x is equal e to power x. And whatever left is our g prime. So this is sine of a minus x. Our antiderivative will be equal cosine of a minus x. You can always check when you take derivative of this expression, you should get exactly the same what we have at the beginning. Now we have to check only if our f and g prime function is continuous because we have definite integral. E to power x exponential function is continuous and sine is continuous function, so everything is okay. Next, we have to substitute to our formula. So this is equal f times g, so we have e to power x times cosine of a minus x, and we have limits from 0 to a. Next, we have minus integral from 0 to a of f prime is e to power x times g is cosine of a minus x with respect to x. So this is equal, we will copy first expression. So we have e to power x cosine a minus x, limits from 0 to a we have, and we have minus. To solve this integral, we will use one more times integrate by parts formula. So let me put here that our f of x is equal e to power x. So f prime of x will be equal e to power x, the same. G prime will be, whatever left is cosine of a minus x. So our antiderivative will be equal negative sine of a minus x. So we can put that we have minus, and in brackets we will put first f times g. So we have e to power x times negative sine of a minus x. Negative times positive give us negative e to power x sine of a minus x. We have to put now limits. We have from 0 to a, and we have minus integral from 0 to a of f prime of x is e to power x, and g is negative. So we have negative and negative. We can change this to positive. Sine of a minus x. With respect to x, we have integral. So we can write, let me rewrite our integral from the beginning. We have integral from 0 to a of e to power x sine of a minus x dx. This is equal, we got e to power x cosine of a minus x, limits from 0 to a, and now we have negative and negative give us positive e to power x sine of a minus x, limits from 0 to a. Negative and positive give us negative, and we have integral from 0 to a of e to power x sine of a minus x with respect to x. We get the same integral which we have at the beginning. So I will move this integral to the left side. So we will have two integrals from 0 to a of e to power x sine of a minus x with respect to x. This is equal, and we have e to power x cosine of a minus x, limits from 0 to a, plus e to power x times sine of a minus x, we don't need this parenthesis, and limits from 0 to a. Now, because we need to find integral of e to power x sine a minus x, so I don't need this 2, we have multiplication here, so I will divide both sides by 2, so this 2 we can reduce, and we will have integral from 0 to a e to power x sine of a minus x with respect to x, and I will put 1/2 before this whole expression because I divide both sides to reduce this 2 on the left side, and in brackets we will put this whole expression e to power x cosine a minus x, limits from 0 to a, plus e to power x sine of a minus x, limits from 0 to a, close brackets. So now we have to plug our limits. So this is equal, we have to copy 1/2, and in brackets first we have to put upper limit for x, so will be e to power a cosine of a minus a, minus lower limit, we have to now plug e to power 0 cosine of a minus 0, plus, and now we have to plug limits to our second expression, so it will be e to power a sine of a minus a, minus, now we have to plug lower limit, so it will be e to power 0 sine of a minus 0, close brackets. This is equal, we have 1/2, and in brackets we will have e to power a, cosine will be 0, cosine 0, because a minus a is 0, cosine 0 is 1, minus e to 0 is 1, so we have 1 times cosine of a minus 0 is a, plus we have e to power a sine a minus a is 0, sine of 0 is 0, minus e to power 0 is 1, and we have sine of a. So this is equal, we have 1/2, and in brackets we have e to power a times 0, we can reduce, so we have e to power a minus cosine of a minus sine of a. This is my solution. First, let me remind you formula for integration by parts. Definite integral, so when we have integral from a to b of f of t times g of t with g prime, of course, of with respect to t, this is equal f of t times g of t, limits from a to b, minus integral from a to b of f prime of t, g of t with respect to t. F and g prime function must be continuous. In our example, we have only inverse sine, so first we can rewrite our definite integral from 0 to 1/2, and we can put sine, inverse sine of t times 1 dt. So inverse sine is continuous, 1 is continuous function, so everything is okay. Let me put that f of t is equal inverse sine of t. So f prime of t is equal 1 over square root of 1 minus t square. And whatever left is our g prime with respect to of g of t is equal 1. So our antiderivative is equal t. So now we have to just plug this to our formula. So we have this is equal f times g. So we have t times inverse sine of t, and we have limits from 0 to 1/2 minus, now we have definite integral from 0 to 1/2 of f prime is equal 1 over square root of 1 minus t square times g is equal t with respect to t. So this is equal. We can copy first expression, so we have t times inverse sine of t, limits from 0 to 1/2, and to solve the second integral we will use substitution method. Let me rewrite this, that this is first we can change square root to power form. So we will have, let me copy integral symbol from 0 to 1/2, and we will put that we have 1 minus t squared to power negative 1/2. I change square root to power form times t dt. So this is equal, we have t times sine, inverse sine of t, limits from 0 to 1/2 minus, and now we will use substitution method. So let me put that our 1 minus t square is equal u. So derivative of both sides now have to calculate, so negative 2 t is equal du with respect to t. So we have to multiply both sides by dt to reduce the numerator, dt and dt, because when we do u substitution, we have to find du. So we had that du is equal negative 2t dt. We have in our integrand only t dt. We don't have negative 2. So now I will divide both sides by negative 2. Negative 2 and negative 2 we can reduce, and we will have that dt is equal negative 1/2 du. So we will have integral from 0 to 1/2 of 1 minus t squared is u to power negative 1/2 we have to copy, and for d it should be t, of course dt is equal negative 1/2 we will put in parentheses du. Because I didn't change the limits, I have to come back to the substitution and the end to t substitution. So this is equal, we have t inverse sine of t limits from 0 to 1/2 minus, and now we have negative and negative, so we have to change this to positive sign. 1/2 I will take before integral symbol, so we have integral of power function formula used to now. So u to power negative 1/2 we have, so it will be u to power negative 1/2 plus 1 over, the numerator is the same like exponent, and we have limits from 0 to 1/2. So this is equal, we have to copy first expression, and we have plus 1/2, negative 1/2 plus 1 is 1/2, so we have to flip this fraction, so it will be times 2 over 1, so I can put 2 times 2, and u will be to power 1/2, limits from 0 to 1/2, so this is equal, we have t times inverse sine of t, limits from 0 to 1/2, 2 and 2 we can reduce, and now we have to come back to substitution because I didn't change the limits, so it will be plus 1 plus t square, we have to power 1/2, so this is square root of, and we have limits from 0 to 1/2. So this is equal, now we have to plug the limits, minus, of course, minus, we have here minus 1 minus t square. Now we have to plug limit, first upper limit instead of this, so we have 1/2 inverse sine of 1/2 minus, now we have to plug 0, so when you multiply 0 times sine, inverse sine, it will be 0, so we don't have to put, and now we have plus, so we have to change the sign, and we have to plug first upper limit, so it will be square root of 1 minus 1/2 to second power minus lower limit, so we have to substitute t by 0 now, so it will be minus square root of 1 minus 0 square, so this is equal, we have 1/2 inverse sine of 1/2 plus we have square root of 1 minus 1 over 4 is 3 over 4 minus we have 1, square root of 1 is 1. So this is equal, we have 1/2 inverse sine of 1/2 and we have square root of 3 over 4, so it will be plus square root of 3 over 2 minus 1. This is equal. We have 1/2. Inverse sign of 1/2 is pi over 6. So we have times pi over 6 plus, and we have square root of 3 over 2 minus 1. So this is equal. We will have pi over 12 plus square root of 3 over 2 minus 1. We can factorize 1 over 12. So in parentheses, we will have pi plus 6 square root of 3 minus 12. This is my solution. We have integral of arctangent for x with respect to x. So first I will substitute 4x by u. Let me put this. U is equal 4x. So now we have to find the root of both sides of our equation. So du to dx is equal 4. Now we will multiply both sides by dx because we need to find du. Dx and dx we can reduce, and we have that du is equal 4 dx. So because we have in our example only dx, now I will divide both sides by 4. So 4 and 4 we can reduce, and we have that dx is equal 1 over 4 du. So now we can rewrite our integral, and we will have arc tangent of u, and for dx we have to put 1 over 4 du. This is equal. We have constant, so we can take this constant before our integral symbol, and we will have integral of arctangent of u with respect to u. Now we can rewrite this and put that we have arctangent of u times 1 du, because we need to have product to use formula for integration by parts. Let me remind you this formula now. I will put this in the right corner. When we have integral of f of u times g prime of u with respect to u, this is equal f of u times g of u minus integral of f prime of u times g prime of u. So our f will be arctangent. Let me put this. F of u is equal arctangent of u, and now f prime of u will be equal 1 over 1 plus u square, and whatever left is our g prime of u. We have 1, so our g is equal u. Now we can use our formula and rewrite our integral. First we have to copy 1 over 4, and in brackets we will have f times u, so we can put u times arctangent of u minus integral of f prime is 1 over 1 plus u square times g with respect to u, of course. I forgot here to put du. So This is equal, we have to close brackets. So first we have to copy 1 over 4 and in brackets we have u times arc tangent of u minus. And now to solve this integral we will use substitution method again. So let me put that 1 plus u square is equal t. So we have 2u is equal dt to du. We have to multiply by du now, both sides, to reduce denominator. So we have that dt is equal 2u times du. So now we divide both sides by 2. 2 and 2 will reduce because we don't have here 2. And we have that du is equal 1/2 dt. So we can come back to our integral and we will have integral of 1 over t, and for u du we just put 1/2 dt. So this is equal. We have to copy the beginning and we can come back to our substitution because u is equal 4x. So we will have 1 over 4 and in brackets we will have 4x arc tangent of 4x minus, and first we will take this constant before integral symbol, so we have 1/2, and integral of 1 over t is natural logarithm of t, so we have natural logarithm of t. We don't have to put absolute value bars because t is equal 1 plus u square is positive always number, so we have natural logarithm of t plus constant, of course. So this is equal. Now we have to come back to our substitution. T was equal 1 plus u square and u was equal 4x. So we will have 1 over 4, in brackets we have 4x arc tangent of 4x minus 1/2, and for t we will have to copy natural logarithm and we will have in parentheses 1 plus u square. U is equal 4x plus constant c, close brackets. So this is equal. We can do multiplication. So 4 and 4 we can reduce and we will have for expression x times arc tangent 4x minus 1 over 4 times 1 over 2 is 1 over 8 natural logarithm of 1 plus 16x squared plus constant c1, because 1 over 4 times constant is still constant. I can put c1. This is my solution. First, let me remind you formula for integration by parts. We have integral of f of x times g prime of x with respect to x. This is equal f of x times g of x minus integral of f prime of x g of x with respect to x. Let me first rewrite this integral. We have integral and we can put that we have x times 1 over cosine square of x with respect to x. So this is equal we can rewrite this one more time. 1 over cosine square will be secant square. So we have x times secant square of x with respect to x. Now we will put that f of x is equal x. So f prime of x is equal 1. Whatever left is our g prime. So we have secant square of x. And antiderivative of secant is tangent. So we have g of x equal tangent x. Now we can substitute to our formula. So we have that this is equal f times g, so we have x times tangent of x minus integral of f prime is 1 times g is tangent of x with respect to x. So this is equal x times tangent of x minus integral we have of tangent of x with respect to x. So this is equal x times tangent of x minus, and integral of tangent is equal negative natural logarithm of absolute value of cosine of x. Of course, we have to add constant. So this is equal, we have x tangent of x, negative and negative give us positive, natural logarithm of absolute value of cosine of x, plus constant c. I forgot to add that our denominator cannot be equal 0, so cosine square of x must be different than 0. So this is my solution. To solve this problem, first we will use substitution method. Let me put that x is equal t cube. So now we have to find the derivative of both sides of our equation. So we have 1 is equal 3t square dt to dx. Now we have to multiply both sides by dx. We can reduce denominator and we have that dx is equal 3t square dt. Now we can substitute to our function and we will have integral of e to power, we have cube root of x, so it will be t cube times dx is equal 3t square dt. This is equal cube root we can reduce with cube and we can take constant before integral symbol, so we have e to power t square dt. To solve this problem, now we can use integration by parts formula. Let me remind you, when you have integral of f of t times g prime of t with respect to t, this is equal f of t times g of t minus integral of f prime of t times g of t with respect to t. So in this example, we will put, because we want to reduce t squared, because derivative of et is still e to power t, so we will put that f of t is equal t squared. So f prime of t will be equal to t. Our g prime is, whatever we left, is e to power t. Antiderivative of e to power t is e to power t. Now we can substitute to our formula. So this is equal 3 we have to copy, and we have now in brackets f times g. So we have t squared times e to power t minus integral of f prime is 2t times g is e t dt. So this is equal, we have to close brackets. We have 3 times, and we have t squared e to power t minus, we have to put constant before integral symbol, and we have integral of t e to power t dt. So again we have to use integration by parts formula. Now we will put that f of t is equal t. So f prime of t is equal 1. G prime is equal e to power t. So antiderivative is equal e to power t. Now we can substitute to our formula. So beginning we have to copy, we have 3, and in brackets we have t squared e to power t minus 2, and we will put in parentheses f times g, so will be t times e to power t minus integral of f prime is 1 times g, so will be e to power t with respect to t. Close parentheses, close brackets. So this is equal, we have 3, and in brackets we will have t squared e to power t minus 2, we can multiply by 2 expressions in parentheses, so will be t e t, negative and negative give us positive, and we will have 2 times integral of e to power t is still e to power t. We have to add constant, of course, so this is equal. Now we have to come back to our substitution, because we substitute at the beginning x by t cube. So our t is equal cube root of x. So we have to now substitute t's by cube root of x. So we have to copy 3, and we will have in brackets, we have cube root of x to second power times e to power cube root of x minus 2 times cube root of x times e to power cube root of x plus 2 times e to power cube root of x. We can take this constant after brackets. So because 3 times constant, it still will be constant. So I can put plus c1. Now we will factorize e to power cube root of x. So this is equal. We will have 3e to power cube root of x, and in brackets we will have cube root of x square minus 2 times cube root of x plus 2 plus constant c1. This is my solution.